Gunjokwa, sawatahunsios kanigariwasa, ne gadi ohandu gariwatekwa angawana hetsu. Agwega aska adita watwet noni ne ungwatni guna, tano dieti nuarado ni negi yung gari staa, ji hadzi segun yugari wat doga, ji nahoda tayat go want haje. Dogadi na yahoda nungwatni guna. Sego, everybody, welcome to the Royal Society of Canada, Canada's National Academy. The Royal Society of Canada recognizes Canada's leading intellectuals, scholars, researchers, and artists, and mobilizes them in open discussion and debate to advance knowledge, encourage integrated interdisciplinary understandings, and address issues that are critical to Canada and Canadians. We are one portion of the RSC that organizes the webinar you're about to be an audience member for. The Royal Society College is one that has organized a number of engagement events, and before us is our webinar that we're hosting in order to engage our membership and others on topics that are really quite important to the Academy in Canada and abroad. Today's event will feature presentations from speakers in both of Canada's official languages. Live AI-generated interpretation of this event is available using Wordly. Will receive an invitation momentarily to access the transcription. If you wish to do so, please accept the invitation and select the language you would like to see transcribed. Today's event is the second in a series of webinars organized by the RSC College. The third webinar on secularism is being planned for early in the new year. Watch for more details coming soon. On a separate note, the college is looking forward to a number of important activities that'll be happening quite soon. The COEE event, the Celebration of Excellence and Engagement, will be taking place November 15th to 18th at the University of Waterloo. Our RSC College Programming event will be occurring on Saturday, November 18th, and that will be an event that focuses upon visible minority experiences in the Academy in Canada. Our ARDA, At-Risk and Displaced Academics and Artists program, continues to this day. It's been going on for quite a while. This program is focused on supporting early and mid-career colleagues displaced to Canada by war, conflict, or threats of violence. The lead in this initiative, Carly Cahoe, would welcome statements of interest from college members who wish to contribute, and there will be some messaging going out to college membership quite soon about opportunities such as this one. I'd also like to make mention that the Massey Dialogues Initiative, a partnership between the Royal Society in Canada and Massey College, will continue. We recently had an event on healthy aging at Massey College. The RSC College will host the third installment of this series of bilingual dialogues on March 7th of 2024. The topic there will be sustainability of our lakes and oceans, and more information, including information of the speakers, will be provided shortly. The second of the Massey Dialogues will be taking place in early December, and that one is on artificial intelligence. So information will be forthcoming before the COEE in November. So we're all looking forward to this. I'd like to now introduce Patrick Leroux, who is the current secretary of the Royal Society's College, who will be moderator for today's event. Patrick.
Thank you. Nyawa Frank. Today's event explores climate change. So from fires to floods, tornadoes to ice storms. The past few years have been essentially seen an unprecedented number of extreme weather events. Climate change has been a growing concern for years, but never before have the impacts of extreme weather been felt by so many across the country. Our responses to these overlapping crises present overlapping questions of science, policy, resources, and will. In this webinar, our speakers will be invited to discuss the ways climate change is touching Canada and the planet, and what can be done and what needs to be done. Je m'appelle Louis-Patrick Leroux. Je suis professeur en double affectation au département d'études françaises et anglaises de l'Université Concordia. Donc, assez loin en termes de recherche compte tenu du sujet du jour, mais comme vous tous, il me touche profondément. Jusqu'à tout récemment, j'étais vice-doyen à la recherche à la Faculté des arts et sciences à Concordia. Frank le disait, je suis également secrétaire du Collège de la Société royale du Canada et il me fait plaisir donc d'animer, de diriger le trafic un peu aujourd'hui et de céder ma place aux véritables experts du sujet que je présente à l'instant. Excusez-moi. Dr. Zander Wang is an associate professor in the School of Climate Change and Adaptation at the University of Prince Edward Island. He is also the director of Climate Smart Lab in the Canadian Centre for Climate Change and Adaptation. Dr. Wang's research is mainly focused on regional climate modeling, climate downscaling, hydrological modeling and flooding risk analysis, energy systems, modeling under climate change impact assessment, and adaptation studies. He also does work on spatial modeling and analysis, big data analysis, and visualization. Our second speaker, Julie Mireille Thériault, elle est professeure donc à l'Université du Québec à Montréal, titulaire de la chaire de recherche du Canada sur les événements météorologiques hivernaux extrêmes. Ses recherches visent à déterminer les facteurs météorologiques, incluant les précipitations, menant à des événements à fort impact. Elle combine la modélisation, les mesures et la théorie pour étudier de façon inédite ces modèles essentiellement. Ces réalisations ont mené à des avancées clés sur la mesure des précipitations, les transitions pluie-neige, la formation du verglas et les changements climatiques en milieu nordique. Alors, si vous permettez, nous commencerons avec Zander et poursuivrons avec Julie. Zander, I'll invite you to start with your talk. You have about 8 minutes. Then we'll move on to Julie's talk, and then move to questions amongst ourselves and from the audience. Zander.
Yeah, thank you so much, Patrick. I think my slide is okay. Yeah, okay. That's great. Thank you so much, everyone. It's really a great honor for me to join this webinar and to share some of our research for PEI. So basically today I will talk about building climate resilience for Prince Edward Island. Okay, so before I start, I certainly want to acknowledge what I live and where I'm doing my research is on the traditional unceded territory of Mi'kmaq people in PEI. So I also want to like to acknowledge, all the work I presented today is like group work, teamwork, and these are all the people behind the scene. And these are some of the group photos we have taken. One of the photos I just want to point to is this group photo in front of one of the iconic teacup site in PEI that was damaged, blown away by Fiona last year. Okay, so why we want to care about climate change? And the big issue here is about this assumption of stationarity. And typically when we design all our critical infrastructure, city water systems, building codes, and water rights, we always introduce this assumption of stationarity, which means we assume that the future will be the same and the future climate will be the same as the past. But however, this assumption certainly will not hold anymore in the context of climate change. For example, what you see here is like taking temperature as the example. Every year we probably see a high, low, this kind of annual cycle. But if you look at long term, we are seeing the temperature is getting warmer and warmer. So therefore, this kind of assumption of stationarity will no longer hold in the future. So that's why we're seeing warming temperature globally. And within the context of global warming, our hydrological cycle has been amplified So if you look at this picture here, we may have increased evaporation from ocean and evapotranspiration from land, and this will cause more intensive precipitation events and resulting more flooding. And in the meantime, some other locations you may receive less water, less rainfall, which means droughts too. Next, please. So when it comes to coastal areas, like Prince Edward Island, we are so extremely vulnerable to climate change. For example, we have sea level rise issue, coastal flooding, erosion, and storm surge, and many other issues. And these are, actually have been affecting our, major economic sectors. For example, our tourism sector is being affected. Our fishery, like lobster, oyster, mussels, aquaculture side is also affected. And the most importantly, the potato farmers in PEI, they have been seeing a lot of changes in the climate weather pattern. This is affecting their potato yield too. So how do we deal with climate change? Certainly there are typically two options, adaptation and mitigation. Some people may say we may have a third option, that is taking no action. Certainly we don't want to consider that option. So when it comes to adaptation, we are basically talking about changing our behavior or our structure or infrastructure to kind of adapt to the changing climate conditions. When it comes to mitigation, this is more about reducing greenhouse gas emissions. And we know that the increase in greenhouse gas emissions is certainly the fundamental reason for climate change. So that's why we need to focus on both. So in our Climate Smart Lab, we are building an interdisciplinary research program towards a climate smart future. And these are several pillars we are looking at. We look at high resolution climate modeling, integrated hydroclimate risk assessment, climate resilient communities, climate smart agriculture, climate change and health, and also climate change impacts and adaptation. Next, please. So today I would like to share just a few of the recent research about from our lab. One is looking at possibility of stabilizing the Greenland ice sheet. So in PEI, we are very low lying, so we are so vulnerable to sea level rise. And the melting Greenland ice sheet is certainly a big driver for the sea level rise. So that's why we want to evaluate the possibility of stabilizing Greenland ice sheet. So we have used a high resolution climate model considering different greenhouse gas emission scenarios. We look at the ice cap climate coverage to see if there is a possibility. So our results shows that RCP 2.6 scenario is the only one with the possibility of stabilizing the Greenland ice sheet. Other scenarios, we will continually see decreasing, shrinking sea ice coverage in Greenland. We also look at future climate projections for Eastern Canada. This includes Atlantic Canada and also Quebec. And this is a summary about results from this research. And when it comes to mean temperature, absolutely everywhere we are going to see increase in temperature, but specifically in January, December, those winter months, we actually may see significant increase in temperature. And in terms of precipitation, generally speaking, we will see more precipitation because we are close to Atlantic Ocean. But one thing one issue is about the drought issue. So if you look at the plot at the bottom left, and it's about August, the purple color shows the decrease in precipitation. And when it comes to PEI, this will be a big issue because in August, we need a lot of rainfall to feed our potato growth. And if we do not have enough water, certainly there will be a lot of impact on the potato yield. And based on that, we also look at future impacts, climate change impacts on potato yield in PEI specifically. And in this table, you are seeing several emission scenarios with different global climate models. And most of them, they are showing decrease. And on average, almost under average scenarios, we may see decrease. And if you look at the high emission scenario, SSP 5.8.5, we may see maybe a 60 or 80% decrease. But this is based on an assumption that we take no action to adjust our farming practices. But certainly this is not true. because in PEI, all the potato farmers, they are aware of this kind of risk. They're actually changing their practices to adapt to the changing climate conditions. So in addition to this large-scale research, we also look at some local monitoring climate network for PEI. And in PEI, we have established several real-time climate-related monitoring network for us to collect enough data to do climate modeling, coastal flood modeling, and overland flooding modeling too. So this is one of the app, which is called PEI Weather and Climate app. It is available to the public. We have over 100 real-time weather stations so far. And this is about PEI Climate Atlas. This is look at, currently we provide 1 kilometer by 1 kilometer high resolution climate maps for the past 50 years of PEI. And this is the PEI storm surge early warning system. This is extremely helpful for local people. They can look at real-time water level to determine this is high tide or low tide. But most importantly, we can use that to monitor the extreme storm events like Fiona. And here, this is one of the screenshots of our PEI storm surge early warning system. It shows the monitoring water level in the Red Hat Harbor. And you can see at last, we captured the extremely high peak. That is a storm surge caused by Fiona. But after a few hours, our station was blown away by the extreme wind of Fiona. And this is another station showing similar storm surge during Fiona. The scale of the storm surge in this station is relatively smaller compared to another one because of the locational difference. Yeah, and we also have climate diary. Again, this is only for PEI at this moment. The idea behind that is to encourage the public to participate in climate monitoring. And this is based on climate citizen science and phenology. One example is that if you see a bird coming earlier in the spring, which means the temperature here is getting warmer. So we basically encourage people to report what they see every year for the first time, so that we can use this information to make long-term statistics to check if all this information has been changing. Yeah, I think that's probably the last slide for my side. Finally, what we are focusing on at this moment, and also it's our research priority is to look at the coastal hazard monitoring, modeling, and testing in the Canadian Center for Climate Change and Adaptation. Because PEI is so vulnerable to coastal hazards, we have established some monitoring network, and we also have some monitoring capacity, like with different HPC. We do ocean wave modeling, flood modeling, coastal modeling, storm surge prediction, and climate modeling too. And finally, we're also establishing some testing facilities, both in our center and also for some in situ monitoring sites. And this is basically to help local people, local communities to find some either nature-based or engineering-based coastal protection measures from the long-term perspective. Yeah, I think that's probably everything I want to share with you today. Thank you so much.
Thank you so much, Sander. So you've given us a whirlwind tour through a lot of research, many complex interdisciplinary connections happening. You've talked about your research in Greenland, in PEI, on potato growth, on water levels. We'll be able to unpack all of this during the Q&A afterwards. Speaking of the Q&A, I'd just like to remind everyone that you can type in your questions in the Q&A functionality. I see that someone has asked, can we get a copy of relevant research papers mentioned in the presentations? So I guess we can put hyperlinks afterwards if colleagues agree. And the other question was, can everyone see the shared screen? So I'm hoping most of you can. I could. So thank you. We'll add those hyperlinks shortly. Moving on to our second colleague, Julie Mireille-Thériault. Julie will be presenting in French. Please know that there is an AI-generated translating machine that you have access to, and the Q&A can be in either French or English, a mix of both, and some robot speaking as well, I'm sure. Julie, à quand vous êtes prête?
Merci beaucoup. Oui, bonjour et bon après-midi tout le monde. Je suis vraiment contente d'être ici aujourd'hui pour vous parler d'événements météorologiques et climatiques extrêmes dans un contexte de changement climatique. J'ai essayé de les illustrer un peu par des petites icônes là, à droite de l'écran, mais comme on le sait déjà, il en existe plusieurs, par exemple des vagues de chaleur, des sécheresses, de la neige abondante, du verglas. C'est souvent, ces événements extrêmes, souvent à fort impact, peuvent aussi se produire en chaîne d'événements, ce qui rend leur analyse un peu plus compliquée. Par exemple, des sécheresses prolongées peuvent engendrer davantage de feux de forêt. Encore aussi, des fortes pluies intenses et courtes peuvent mener à des inondations éclairs ou des redoux en hiver peuvent mener à du gel de l'eau qui s'est accumulée au sol quand les températures redescendent. Nous avons vu plusieurs de ces événements extrêmes dans les dernières années au Canada et dans le monde. Puis les études nous démontrent que l'intensité et la fréquence de ces événements vont augmenter avec les changements climatiques. Il est donc essentiel de mieux les comprendre afin de mieux pouvoir les anticiper dans le futur. Donc, on peut utiliser plusieurs méthodes ou plusieurs approches pour étudier les événements extrêmes météorologiques et climatiques. On utilise, par exemple, des modèles de climat. On fait des calculs sur ordinateur pour calculer le climat passé, mais aussi le climat futur. On peut utiliser des modèles climatiques à différentes résolutions spatiales. Par exemple, si on a des résolutions spatiales plus grandes, pour représenter toute la planète, ou après des modèles régionaux qui représentent, par exemple, un continent en particulier. Puis après, on peut y aller avec une loupe puis regarder avec des modèles à plus haute résolution pour avoir plus de détails sur une région en particulier qui nous permettent de mieux décrire la topographie, la surface et de raffiner aussi les processus qui permettent de bien représenter les nuages et les précipitations dans les modèles. Pour voir si notre modèle il fonctionne bien, on a aussi besoin de réseaux d'observation. On fait une évaluation du modèle, puis après, ça peut nous donner confiance dans les projections qui sont faites. Donc, si on fait des expériences dans la communauté scientifique, un peu comme Zender a montré juste avant, il peut y avoir des projections climatiques qui sont faites sur du long terme avec les modèles globaux, par exemple, puis on utilise des ensembles de simulations pour avoir un ensemble de réponses, pour avoir un éventail de réponses par rapport aux températures et aux précipitations, par exemple. Mais aussi, on peut utiliser d'autres méthodes. Par exemple, on peut utiliser la méthode qu'on appelle où on donne une perturbation de climat plus chaud et plus humide à notre climat historique. Puis ça nous permet de regarder les rétroactions à fine échelle et la rétroaction thermodynamique. Qu'est-ce qui va arriver thermodynamiquement à une tempête qui est plus chaude et plus humide dans le futur? Donc, dans les études qu'on a faites depuis les dernières années, on a utilisé cette méthode-là, puis j'ai pensé aujourd'hui vous présenter quelques résultats. Ces travaux sont faits évidemment en collaboration avec plusieurs chercheurs à travers le Canada et aussi aux États-Unis. Donc, la première chose que je voulais vous parler, c'est les changements dans les températures proches de zéro dans le sud du Canada. L'hiver s'en vient, l'automne est arrivé, les températures commencent à descendre. Probablement, il y a des régions au Canada où il fait déjà 0 degré Celsius. Puis on était curieux de savoir, est-ce que ces conditions vont persister dans un climat plus chaud? On pourrait s'attendre que non ou que ces événements-là pourraient diminuer. Mais avec les calculs de changement climatique, on s'est rendu compte que c'était possible que ces événements-là soient maintenus ou même peut-être augmentés avec les changements climatiques. Qu'ici, sur la carte, j'ai montré ici les différentes possibilités. Par exemple, ce qu'on a fait, c'est qu'on a regardé une distribution des températures auto-horaires, pas journalières, mais horaires, qu'à une résolution vraiment fine. Puis là, on regarde dans le diagramme d'en bas les différentes possibilités. Est-ce que les conditions, est-ce qu'il y a un maximum à zéro? Est-ce que c'est un maximum absolu ou relatif? Puis ensuite, comment ces maximums vont changer dans un climat futur? Celle-là de droite est historique, celle-là de gauche dans la légende est future. On se rend compte qu'à travers tout le Canada, même s'il fait plus chaud, les conditions proches de zéro seront maintenues. Après, on remarque que le rouge, il va avoir une augmentation, mais le vert, ça veut juste dire que le maximum absolu n'est plus à 0 degré Celsius. Fait qu'environ 95 du territoire du sud du Canada, là, dans notre domaine, va avoir des conditions de 0 degré importantes dans un contexte de climat plus chaud. Ces conditions-là, ils sont maintenus parce que quand on a de la fonte ou du gel, ça tend les températures vers 0. Ça fait que si on a des précipitations qui tombent, si on a de la neige au sol, on peut avoir ces types de processus ou de changements de phase qui veulent ramener la température à 0. Puis après, si on a d'autres facteurs, comme par exemple la couverture nuageuse, la vitesse de propagation des systèmes météorologiques ou encore le cycle diurne, ça va aussi influencer ces conditions proches de 0. Fait afin de mieux comprendre ce qui se passait, puis aussi de voir qu'est-ce qui s'est passé dans le climat passé, on a fait une étude, par exemple, sur tout le Canada et une qui vient d'être acceptée pour publication sur Terrasse en Colombie-Britannique, parce qu'on s'est rendu compte qu'à Terrasse, c'est l'endroit où il y a plus de conditions proches de 0 au Canada. Ça peut durer jusqu'à 10 jours et c'est souvent accompagné de précipitations. Ensuite, des conditions proches de 0 accompagnées avec des précipitations, on en voit aussi dans l'est du Canada, par exemple durant des tempêtes de verglas. Et j'ai pensé ici énumérer 2 exemples. Un de la tempête de janvier 2017, où beaucoup d'accumulations de verglas, jusqu'à 50 mm, ont accumulé à la surface. Ça a causé beaucoup de dommages au réseau électrique. Et aussi tout récemment dans la région de Montréal, en avril 2023, où aussi une trentaine de millimètres de verglas s'est accumulé. Ici, c'est 2 exemples, mais c'est sûr que le verglas peut se produire aussi à travers le Canada. On est pensé, OK, et si on étudie les changements d'occurrence de pluie verglaçante dans un contexte de climat plus chaud et humide, qu'est-ce qui va se passer? On s'est dit, bon, probablement qu'il n'y aura plus de verglas, mais non, parce qu'il peut y avoir des conditions atmosphériques qui sont un peu plus complexes ou à fine échelle, des rétroactions qui font que le verglas pourrait rester dans un climat plus chaud et humide, tout dépendant évidemment de la région d'intérêt. Mais le type de précipitation qui arrive à la surface dépend des conditions atmosphériques en altitude. Par exemple, ici, j'ai illustré 2 scénarios. Le scénario 1, où on a, par exemple, de la glace en altitude, fait qu'on a de la neige ou de la neige givrée qui va tomber à travers une atmosphère où il y a une couche d'air chaud et une couche d'air froid juste en dessous. Fait que le diagramme en dessous, l'axe Y est l'altitude et l'axe X est la température. Donc, ça nous donne un peu la distribution de la température au-dessus de nos têtes dans l'atmosphère. Le scénario 2, on voit que la température est seulement sous 0. Donc, dans le scénario 1, qu'est-ce qui peut se passer? Si on a du verglas ou du grésil, les flocons de neige qui vont tomber dans la couche d'air chaud peuvent fondre complètement ou partiellement, ensuite regeler ou pas. Mais qu'on se demande, avec les changements climatiques, qu'est-ce qui va arriver? Est-ce que ce profil de température va augmenter complètement au-dessus de 0 ou est-ce qu'il va y avoir quand même des effets locaux qui rentrent en jeu pour maintenir en particulier la couche d'air froide proche de la surface? Fait que c'est quelque chose qu'on a vu dans les calculs, c'est que, par exemple, on voit dans la vallée du Saint-Laurent, dans l'est du Canada, que la présence de la vallée du Saint-Laurent, à cause de ça, ça va maintenir l'air froid dans les basses couches, qui va maintenir l'occurrence de verglas dans un contexte de changement climatique. On a remarqué aussi que le même processus ou un processus similaire se passait dans le sud-est du Nouveau-Brunswick à cause du mont Carleton, mais avec le réchauffement ou avec les simulations qu'on a avec un climat plus chaud et humide, on remarque que ce n'est pas suffisant pour maintenir le verglas dans cette région-là. Ensuite, on s'est rendu compte avec nos calculs qu'il y avait un deuxième scénario qui rentrait en jeu et qui pouvait éventuellement jouer un rôle important, c'est la présence de nuages où il y a juste de l'eau dans les nuages. En fait, ce qu'on voit, c'est que dans l'atmosphère, l'eau ne gèle pas à 0 degré Celsius, mais l'eau pure va geler à moins 40. Fait que c'est commun de voir des nuages en phase liquide seulement quand les températures sont moins 10, moins 15. Et c'est normal aussi de voir des nuages qui sont en phase mixte. Donc, dans un contexte de changement climatique, s'il y a un réchauffement, les nuages, peut-être en phase mixte, peuvent devenir des nuages qui sont plus en phase d'eau liquide. Donc, quand les précipitations vont tomber à travers l'atmosphère, ça va arriver à la surface en tant que goutte de pluie et il n'y aura pas eu de phase de glace comme processus. On s'est rendu compte que ce processus était quand même pourrait être important dans nos calculs sur la côte nord, par exemple, du fleuve Saint-Laurent, où on a remarqué que l'augmentation de verglas à cet endroit-là en particulier, 25% étaient associés à ce phénomène-là. Donc, ici, quand on regarde les différents scénarios de ce qui pourrait se passer en altitude, on remarque que ce n'est pas juste une ligne de verglas, par exemple, qui va se déplacer vers le nord, mais que cette ligne, cette distribution pourrait aussi devenir plus large parce qu'il y a des phénomènes qui restent plus au sud, même dans un contexte de climat plus chaud. Donc, la prochaine diapo, c'est la dernière. Et ensuite, le message à retenir, on a besoin de plus d'outils pour étudier, pour mieux comprendre l'évolution des phénomènes. On s'est rendu compte que des processus physiques dominants pourraient changer et on a besoin de mieux comprendre qu'est-ce qui se passe. Puis même s'il va faire plus chaud, on va encore avoir des conditions proches de zéro, puis on pourrait continuer à avoir du verglas aussi. Merci pour votre attention.
Merci, Julie. Perfect. Nous passerons donc aux questions en français ou en anglais, les questions. Si vous permettez, je commencerai peut-être avec une première question, puis on le temps de donner la chance aux gens de réfléchir aux questions et de les mettre sur le Q&A. Peut-être, Julie, I'll ask the question in English. Could you tell us a bit the difference between the ice storm phenomenons that we saw in Eastern Canada, the big ice storm of 1998, and the pretty big one also we had quite recently in April, just this last April, which hit us very hard in Montreal. Are we looking at the same phenomenon or something fundamentally changing?
Donc, on regarde un phénomène qui est similaire parce qu'on avait une couche d'air chaud en altitude, une couche d'air froid proche de la surface. La grosse différence, je dirais, entre les deux, c'est la température qui a suivi la tempête de verglas, parce qu'au mois d'avril, le lendemain, il faisait 15 degrés Celsius, même un peu plus, tandis qu'en 98, le lendemain, il faisait plus autour de moins 20. Donc, les impacts ont duré beaucoup plus longtemps. Après, l'autre chose, c'est l'accumulation de précipitations puis la durée des précipitations, mais quand même, à Montréal, on a eu une trentaine de millimètres dans l'après-midi, tandis que le 1998, ça a quand même duré 4 jours. Mais il y a eu quand même, en 2023, beaucoup de verglas dans peu de temps et les températures étaient vraiment très proches de zéro. Donc, quand la prévision de la tempête a été émise, on s'est dit probablement que ça va monter au-dessus de zéro, mais non, elle a resté là assez longtemps, ce qui a causé beaucoup de dommages. Je dirais la quantité, la durée et les températures suivant l'événement.
Et est-ce que c'est un phénomène, à votre avis, qui est appelé à se répéter de plus en plus souvent?
C'est difficile à dire, mais on a tous les ingrédients, surtout dans la région de Montréal, pour avoir d'autres événements comme celle-là. Ce qu'on a vu, en fait, ce qui était surprenant d'avril, c'est qu'il est arrivé tard dans la saison. Il faisait déjà chaud, mais il faisait assez froid pour avoir du verglas. Puis ce qu'on voit dans nos calculs, c'est que l'augmentation serait plus au mois de février. Puis après, il y aurait des diminutions pendant l'automne et le printemps. Mais là, on a eu une surprise au mois d'avril.
Okay, merci. I see there are 2 questions. Perhaps I'll start with the second one since it's in tune with what we were just talking about, and then move on to the first one. So in February 2023, there was a damaging cold outbreak that impacted the agricultural sector in Atlantic Canada. Will these phenomena become more or less likely in a changing climate? So it's a similar question to the one I was asking about Montreal ice storms, but this is applying also across Atlantic Canada and its impact on agriculture. Who would like to address this?
Maybe you want to go first, or?
Sure, go ahead.
Yeah. Well, I think, certainly that's one of the extreme kind of events we're talking about. And we are really not only talking about those, heat wave or extremely hot extremes. Sometimes you also see these extremely cold situations when it comes to climate change. I think this is really a good point to point out, because a lot of people, they may see, well, we may see experienced a cold event maybe recently, they kind of change their mind, saying that probably the temperature is not getting warmer here. I think that's kind of remind that the climate extreme is kind of happening, not only like, we're talking about the average, but also we're talking about, the outliers with what, compared to the historical, records. We don't have that information certainly for Atlantic Canada yet, but I think with our data, we will certainly be able to look at this kind of extremely cold events. Typically, people, when it comes to temperature, most people will look at the higher end, which is like the extreme hot, heat. But I think this is less important compared to most of the cases. But I think I don't have that information at this moment, but I think if necessary, we can certainly look into that.
Thank you. Judy,
Yeah.
would you like to add to that?
No, I think Zander answered. Yeah.
Perfect. And there was an interesting, very precise question, technical question, maybe following up on this. Dr. Wang, are there any de-icers that can be used to protect electricity supplies in ice storms?
Well, that's a good question for me. I'm not aware of that. I think certainly there will be some from material side or technology side for those ice storm. Perhaps certainly I think there will be some technology available. But when it comes to this event, it happens so quickly and so suddenly, and it will destroy or damage the electricity line, significantly. I think even though we can apply the de-ice technology, probably it's a little bit late until it happened. But I don't have any knowledge into that technology. Maybe I'll turn this over to Julia if you want to add something.
That's a really good question. Also, I don't know. I thought that some of the infrastructure were heated a little bit already. So, but I'm not sure if it exists any device to de-ice the electrical power infrastructure.
So certainly a research question to
Yes.
look into as a complementary one to what you're working on. That's great. There was also a question pertaining to the Green Line ice mass. So this is for Zander Wang. What was the scenario in which the ice mass didn't melt? I think there's a question as to which number, which percentage that was.
Yeah. In that study, we looked at the 3 emission scenarios, which includes RCP 2.6, 4.5, and 8.5. So RCP 2.6 is only one showing the possibility of stabilizing the Greenland ice sheet, but that is only after 2050. It's not like immediately you will be able to do so. But also the indication from that scenario is we need to really take immediate actions to make sure we can follow the RCP scenario trajectory. If we do not take any action now, we are very likely to enter RCP 4.4 or 4.5 or even higher emission scenario, which means we probably will lose the chance to kind of stabilize Greenland ice sheet. Yeah, but its short answer is RCP 2.6. Yeah.
Right. And I can see from your perspective, from your vantage point and low-lying PEI, that you're looking at this very, very carefully. And do you see, are there studies that are sort of correlating the melting and the rising of the ocean specifically on Canadian shores that you can talk about? Or am I going going off out of your expertise and off topic?
Yeah, maybe. Yeah, sorry for based on my expertise or experience. I think certainly sea level rise is certainly a very important issue when it comes to low-lying areas, coastal communities. But another thing we are seeing, I guess, from coast to coast in Canada is we are seeing less sea ice coverage in winter. Usually, like for example, in PEI, in winter, if we have more ice coverage, and which will protect us from the extreme storm, like big wave coming, and this will slow or maybe protect the land from erosion. But what we have seen recently is that we are seeing shrinking less sea ice coverage in winter, and then more people will see local people, with oceanfront properties, they are seeing more erosion because of the less sea ice coverage. Yeah, I think that's only an obvious situation we have experienced. And plus, another thing is about the intensive or this kind of unprecedented, hurricane or post-tropical storm coming to Atlantic Canada recently. This year, we were so fortunate, even though we have 2 storms, but they didn't pass through PEI. But last year, Fiona was, really, unprecedented damages, caused by that. Yeah.
All right, thank you. I guess there's a question following up on Greenland. Volcanism is an important, significant part of the Greenland ice sheet. Can you do anything about that at all? Is there any way of using this productively? I think is the question.
Well, that's a good question for me. I don't have fully, full knowledge about that. I think certainly I agree. That's only a significant part of that. But from my perspective, probably really we can do very little about that. It's more about, when it comes to Greenland, it's more about we need to think about global efforts to really reduce greenhouse gas emission, immediately. So that's something I think from my perspective, it's probably the most important, direction we should go. Yeah.
Great, thank you. There's a question about PEI from Jim Abraham. So PEI is one of the first provinces to make flood risk maps public. And I know, yeah, we've seen those in Quebec as well. And many of us look at them as we purchase houses and cottages near lakes and rivers. Xander, is there a negative reaction from the public who are worried about property values, or are they happy to know that there's risk so that they can adapt?
Well, that's a good question. Well, I can tell from our experience, the provincial government have issued, released the coastal flooding map, publicly. Everyone can have access to that. I think the people we are seeing that they're not happy with about that is probably the real, realtors. Sometimes they kind of try to hide this kind of information from, the clients. But generally speaking, I think most of people, they are happy to see that, either from the existing, residents in those areas, vulnerable areas, they kind of understand what would be the future flooding risk in that area. And also for some people moving to PEI or considering buying some, waterfront properties, certainly this is really extremely helpful for them to get some scientific information to make a good decision for maybe for the next generation to come. I think overall, I really don't see too much negative, but still some people certainly, it's more like, for short term, they may want to hide this information for certain purposes. But overall, I think this is a long-term trend, making this kind of information publicly available to the general public. I think that's a long-term trend. I think that's really the good direction we should go.
Right. So above board, make it clear, share the information, learn from it. Judy, would you like to add anything to that, or this issue of making the information clear and in terms of the flooding zone risks and maps? Does this apply to your research as well in terms of ice damage risks?
That's a good question. I didn't think of this in particular for my research. I think that now people in Montreal look at trees differently, maybe, because we see that like all the damage done to the trees. So it's not related necessarily to the flood map, but a lot of the damage from the ice storms and also like major wet snowstorms when they occur early in the season, it makes a lot of weight on trees, and it's the trees that damage after the power lines if they are not buried underground. So there was a big discussion on news, I remember, after the ice storm, what to do with this. So I think there's no clear answer. but it's definitely something I think to keep in mind, because I was thinking about that too when the question about de-icing the power lines. There's de-icing the power lines, but it's not only the power lines, the weight on the power lines, it's what can fall on the power lines as well, then can cause damages. So I'm not sure if there's a reflection about this, that it's being done or not.
Yeah, thank you. And it's interesting because we've been so proud of our trees and coverage, and we seek out trees to reduce the zero cella, heat islands, heat hotspots. And yet in the winter, in the past few years, in the past 10 years, certainly in Eastern Canada, this has become an issue. The trees end up being the problem with the power line. So yes, we need to expand our view of things. There's a question that someone hates to ask, but I hate to ask this question, but whom else can I ask? What is your opinion on putting carbon black or some other particles in the upper atmosphere to buy us some time while we deal with fossil carbon? So is this viable? Is this possible? Is this something that you consider? Either one, both.
Julia, you want to go first? It's a challenging question. Yeah.
Well, that's a really good question. I'm not sure what to think about this. Like, I think there's two folds of this. So there's like the scientists to be able to study an effect in particular, maybe. Because I see a parallel with what is done, for example, in weather modification in cloud physics, where some iode d'argent, for example, are put into the atmosphere to produce clouds because you want more snow to produce electricity, or you want to avoid of rain. So anyway, there's some ethical questions there of putting particles in the atmosphere to modify the weather, to modify the climate. But also these are also helpful to better understand what happens in the atmosphere and what are some, so because the atmosphere, it's hard to reproduce, it's hard to observe it without perturbing it as well. So, but it's very hard to answer this question. It's a very good question.
Yeah. Thank you so much, Julia. I think I want to add. I think, I know there are quite a lot of research out there to look at potential objects in this way. But from my own perspective, certainly I think it's more like, you're a doctor, you're looking at the issue, you really want to find the fundamental issue. And we know that the climate change is caused by greenhouse gas emissions. So really you want to look into that directly to resolve that. But the person answer this question raised a good point. People may think, well, certainly we are doing this, probably we want to buy a little bit more time so that we can kind of come back to reduce greenhouse gas emissions. Yeah, I do agree with that, but certainly I think there are a lot of issues when it comes to you do some modification to the natural atmosphere. Ethical side also, there are a lot of other potential impacts. You can imagine like some locations people talk about the air pollution probably can help temporarily save us from the extreme heat because you block the sunlight away, or the volcanic eruption. But I think these are all like short term. We need to really think about the long term. I don't have an answer, but just want to share some of thoughts about that. Yeah.
Thank you. And I know Frank Deere has been wanting to ask a question as well, but we don't have access to the Q&A functionality. So Frank, would you mind asking your question out loud?
Yeah, absolutely. Now I'll go to both Julie and Xander for this their lovely presentations here. I'm not a climate scientist. I'm hardly a scientist, but the topics are of important significance for all of us, of course, climate change and its related effects. Julie spoke about climate change in some particular contexts that can, in my mind, I'm thinking about things like transportation issues, livelihoods affected, things of that sort. Xander was talking about such things as agriculture, things that are really important to the well-being of populations and people and such. And these activities ought to be of concern for various levels of government. So I'm wondering if either Julie, I'll focus on Julie first because she appears first on my screen, and Xander can comment at all. You know, do you have a sense about the current interface between various levels of government and experts who have expertise in climate change in the here and now that may affect, if followed up on appropriately and reasonably, for the benefit of our societies? Any anecdotes that you might give us that offer a sense of the challenges we have for municipal, provincial, federal, even international levels of government to do what is necessary, especially with regard to regulating industrial activity? I'm just wondering if you have a sense of the interface between your areas of expertise and scholarship and the people in Parliament, in the legislatures and such.
That's a very good question. I think that yeah, I'm not sure how to organize my thoughts here, but I think that a lot of what I presented here were fundamental research, but also research that were motivated by users. Like they want to know more about ice storms. Does that still be occurring, and how and where, and what do we need to consider? And from this, then we learn a lot, and a lot of these knowledge transfer. Well, some of it have been applied to Environment Canada and eventually being put in weather forecasting models. It takes time, but some of those processes were shown, like the partial melting of snow, that it is important to have it, and it's worth putting the effort to include those into our, and then with the government. So we've done with the Global Water Future some meetings with the Parliament talking about water. It was oriented across on water, in particular flooding as well. So there's aware of the importance, how important it is to better understand those extreme events. And then the Canada Water Agency was formed as well, based on that. So it's done on various levels. I've done a small project with the city of Edmundston, for example, who are interested to know more about their snowpack and when it would flood. And now this summer they had this intense rain that led to flooding and landslides. And so suddenly they were looking at floods, and now they're looking at that short-term intense precipitation. So I think there's like the government of Canada, but also there's like, it's regional. And then with climate change, their focus or importance may also change a little bit. Now we're thinking about floods, but there's floods during the spring, but now there's like these huge floods during the summer because of this intense rain. So I've been in contact with various levels of government and the municipalities as well, and some of the private sectors as well, in particular, like, for example, Hydro-Québec and B-Power and Manitoba Hydro. So there's some interest to know more about those extreme events and how they can adapt their infrastructure. How will it change?
Thanks, Sandra. Would you like to add anything to that?
Yeah, probably just one, I think, example from PEI side. I think everyone knows PEI is so small, so I think, but there's a really good benefit here. I do see from our perspective, we have been working with provincial government, municipalities, and local communities, in many kind of like decision making or policy making when it comes to climate change. I think one of the important part to kind of force, or maybe kind of, I should say, like positively, it's like to encourage the interaction between people, researchers, and the government side is about the public driving awareness in terms of the climate change, because the government is serving the public, so everyone is serving public. So therefore, in PEI we have a very high awareness of public awareness of climate change, because everyone is at the front line of climate change. So they know that. So that's why they want to really take some action. So this will force the government to think about their policy, their action, and then they will make some certainly budget available, and also make some plans to get public engaged and municipality engaged, so that they can make a plan workable for everyone. So I think this is something that that is happening in PEI, but I think the public awareness is certainly the driver to that. Yeah.
Yeah, thank you both. And what I'm hearing is basically fact-based research is key to informing the general public, policymakers, regulators, and finding ways to motivate us to be active in this changing environment, fundamentally changing environment. We obliquely answered the two questions that are still up in the Q&A through Frank's question. So I'm sorry I didn't address these specifically, but I'm receiving a message telling me to wrap it up. And so I will. Frank, would you like to say a few words?
Yes. It's been great hosting this installment of the webinar series, and I'm really looking forward to the future of this series and other things that are going on within the Royal Society of Canada's College of New Scholars, Artists and Scientists. I'd like to thank Xander and Julie for their learned comments on their respective areas of expertise. It's been great listening to you. I want to thank Patrick, who stepped in as moderator for this, as we value as a secretary of the College Council. We value you as a member. We value you as a moderator. You've been great, Patrick. I want to thank the folks at Walter House who make this possible. Russell McDonald, Paige Beveridge, and Amelia Domaradsky, I hope I pronounced that correctly, who do a lot of the heavy lifting when it comes to preparing us for events such as this. Now we'll go to you all and the folks at Walter House. This event will be posted on YouTube in the near future. So if you wish to look at it again or pass it along to colleagues, we will send an email notification. It'll be made available on the various social media platforms. And we are looking forward to the next webinar, which is planned for early 2024 on secularism. So on behalf of the Royal Society of Canada and the College of New Scholars, Artists and Scientists, Nyawangoa, thank you for joining us, and we hope to see you soon. Nyawangoa.
Merci, au revoir.